Hello, everyone. My name, of course, is Jennifer German, NASA JPL Solar System Ambassador, and today is session 5 of Train Like an Astronaut at Home. This session is science. Every astronaut is a scientist. So we're going to learn some of the principles of that. Few things to get right now. Your mission journal, if you have one. Something to write with, of course. I actually remembered today. And your microbial box. Now let's see. I remember writing down, so I went back that first day, there's my sheet, and at the bottom I put where I had put my microbial box. So I can go get it. Here we are for a little bit later in this lesson. Okay, so if you don't already have those things, go ahead and go get them right now. Again, take your mobile device or your laptop with you, send your adult, or just hurry off and get it and come back while I do this little introduction. So, last reminder, trying to run this at 3 levels: younger children, older children, teens, and adults. So younger children, we've not expected you to be keeping track of anything or keeping a mission journal unless you wanted to. And if you did, pictures are completely fine. You don't have to be writing words. Older children, also mission journals, optional. Even if you didn't have one, if you've just been taking notes along the way or even have a pretty good memory, that'll help you a little bit later. If you are keeping a mission journal, then was expecting you to at least write the date for everything and a couple things, but again, pictures, absolutely acceptable instead of writing. Teens and adults, I've been expecting you to keep a mission journal, and we will deal with that, talk about it later. Options throughout the session. This session actually, not exactly a lot of options. It's much more about learning and thinking. So obviously there can be variations in how you think compared to someone else, and what you think options are, and that's great. But it's not so much like the exercise where you can do a sit-up in different ways or any of the activities in different ways. And as always, if you need more time and you're watching this not live but later, pause the video, no problem. All right, let's get started. Science. It is science today. First, just a few principles about science that we're going to talk about. There's something called quantitative and qualitative, and they sound a lot alike, and we're not used to a lot of words in our daily lives that start with Q, QU. So I remember as a kid getting these two confused a lot. Here's how I remembered. Quantitative is quantity, that's numbers. Qualitative is to qualify something, to describe it, that's descriptions. That's how I remember. Quantitative data for science versus qualitative data for science. Okay, skeptical. Good scientists are thought to be good skeptics. That means don't just accept what you see. You ran an experiment, you watched it, you wrote everything down, that's great. But to be a good scientist, you then need to think more about it. Try to explain what you saw. Why does it support your experiment, what you were trying to find out? Or why does it not support what you were trying to find out? And even if it does, question your own findings. Just because you did an experiment to prove something and it worked, could something else have happened that makes it look like it worked, but it really didn't? Scientists always need to be thinking about these things. And lastly, control. So a control is some part of your experiment that you put in that you then do not change. It should match what you start with. So you have 2 of the same thing to start. And then one you're going to do the experiment on and the other one you're not. And that way at the end, you can compare the 2 and see if your experiment actually worked. Okay, let's do some examples of quantitative data and qualitative data. If you were keeping a mission journal and you were writing down stuff along with me, then you should have both in here. Let's see if we can find some. So we're going to go straight to our everyday activity, the spacewalk, right? Crab walk, bear walk. I said those backwards, it's okay. And how we felt. So what do you think? So we're looking at this. I wrote down bear walk, 30 feet, and then I made it all 30 feet. Crab walk, 30 feet. I only made it 21 and a half feet that first session. And how I felt tired, and the back muscle, my right side is strained. So if I'm looking at these things and I'm trying to define quantitative data, quantities, numbers, what do you see? 30 feet, 21 and a half feet. That's quantitative data. What I had marked out to do, how much I actually made it. Qualitative data. Well, what did I do? Qualify it. I did the crab walk. And it would have been even better if I had written down that means hands and feet facing the floor, facing the ceiling, and get my bottom side off the floor. All of that is qualitative data. Identifying how I felt, soreness in my body parts, so my back, qualitative data. What else have we got? Let's see. The touchdown Charlie routine, right? Okay, so I wrote down everything that I did in it, and then at the bottom, I wrote down how long it took me, how many times I did it, and how I felt. So what's the quantitative data? Well, time, 1 minute, 12 seconds, those are numbers. That's how long it took me. That's a quantitative piece of data. How many times did I do it? 2. There's another number. How did I feel? Is that quantitative? No, that's qualitative, right. I'm describing. I felt out of breath, but I felt pretty good and like I had more energy now. Also, just literally defining every step of it along the way. Quantitative data, all good stuff. Okay, you can go through your mission journal and look at all the other things, or if you just took notes and didn't have a mission journal, all of that stuff, and see if you can find other quantitative data and qualitative data, and see if you can just say which is which. Now, for some of these other principles, I'm going to walk you through an example experiment that I did here at home with my children. So this experiment I found at NASA Space Place. The website is there if you're interested. It is a kids science website, spaceplace.nasa.gov. So really not geared for adults, and even teens might find it a little young. But for children, it can be pretty fun, or at least interesting with some of the experiments and explanations. So I found this one about using sunlight, UV light, and sunblock. Sunblock blocks the UV part of sunlight to keep it from hurting our skin. And here's an example experiment about that. Can we see the sunlight hurting things, and can we see sunblock stopping it? And something happened. I don't know what. I do know what. I put my mission journal on the mouse. That's what happened. Let me fix this. Okay, so here's the setup I did. We each took a piece of paper in our favorite color. We put sunblock on the palms of our hands thickly, and then pressed our hands really hard on the paper. Then put it outside, okay? And I took a picture when I put it outside. Well, 2 actually, but that's all right. Then 2 hours later, because that's about how long sunblock works, depending on your sunblock, we went out to check it. And I took another picture. Now here's all the information I wrote down when I did this experiment. I put the date. I wrote down what it was. Sunblock on colored paper. Okay, now something's really having a problem. Turn that off. And try this one last time. All right, wrote down what it was. I wrote down the times as quantitative data also for this experiment because in this one it mattered. So 11:49 a.m., put the papers out in sunlight. I wrote down that I took my first picture at 11:51 a.m. Okay. At 1:49, I went back out, actually a few minutes before, and saw that the papers were no longer in sunlight. So I moved them at 1:49 back out into the sun. I then went and grabbed my camera and took a new picture, 1:55 p.m. When my children and I went back out later to check it again, we saw that the pink paper was no longer in sunlight. There had been enough shade come in. The other two were still in the sunlight, but I took the pink one and I moved it on top, so that was back in sunlight. Then at 3:44 p.m., I took two final pictures. That was the end of our experiment. So 11:49 a.m. to 3:44 p.m. was the length of our experiment. That was about 5 minutes short of 4 hours. Looks like it's a success. We had written down the papers appear to be lighter than when they start at the start. So here are one of my start pictures and one of my end pictures. Okay. So here are my pictures, one of them from the start that I took and one of the end ones I took. And the experiment looks good. I mean, look, it looks like the papers are faded, right? The sunblock is still there. You can see that it's dried. You can see in the start picture on the top, the dark blue, there was some really extra sunblock just laying there, the white. And in the end picture, you can see it's dried. There's a darker black ovalish, blue ovalish spot, but otherwise it's all dried up and gone in the sunlight. I mean, this looks good. This looks like a very successful experiment. But we need to be skeptical. Okay, what does that mean in this case? What are some problems here? Well, can you think of any that might be problematic with the experiment I did? I did. First of all, these two pictures of these papers are not in the same location. If you remember in my notes, I said that the three papers were not in sunlight after 2 hours when I went and checked on them, and I had to move them. That could be a problem for data, for science, for making sure that the experiment wasn't messed with. Okay, but you know what? I can fix that, right? I moved the papers, I took new pictures, we're gonna call that our start over. 2 hour mark, and then end at the 4 hour mark. All right, so that problem is fixed. And you know what? Still looks good. I mean, I'm looking at the pictures, the papers look faded. Still see the handprints where the sunblock is. Seems good to me. Okay, next problem. Remember in my notes I mentioned the pink sheet of paper was not in the sun for the whole time. So we have a couple options for that. We can ignore it, take the pink paper out, take the data out of the experiment and say, sorry, there was a problem with it, we can't use that data. But that's okay in this case. We still have blue, we still have purple. Or we could decide to use it and say, well, yes, the pink wasn't in the sun for the full 4 hours, but you can see it's still faded. There is still sun damage, even under 4 hours, under 2 hours. Now the problem here is how long. We don't know how long the pink was in the sun. Both times, I had to move it. I didn't write it down. So the solution to that is to do another experiment. And that's okay. Scientists are doing that all the time. They run an experiment and something went wrong, or they ran an experiment and saw something they didn't expect. So they run another one to try and figure out what happened, or to try to explain something, or to make their original experiment better. It's good science. It's okay. Okay, what is there another problem? Here's another problem I thought of at the end of this experiment. Does this really show what we're seeing? And what I mean is, colors are subjective. Different people see them in different ways. Cameras, especially, can take pictures, the same picture, differently. And because the sun was in a different position, because anybody had used it between the first picture, the second picture, anybody could have changed settings and I wouldn't have noticed, or even just focus. So I tried it. I took a second picture at the end, and you can see the middle picture here now and the far picture were both taken about 30 seconds apart. The end picture looks a lot like that 2 hour picture. Doesn't look like anything has changed. So if I chose To use the middle picture, I could show, look, my experiment worked. If I chose to use the end picture, I could say, look, it didn't work. Nothing changed. So how do I know which is actually right? The answer is I don't. It's too subjective. It's too variable. What can I do? Well, scientists have a way to help with this. Do you remember that last thing I put up from back when we first started? Something very important was missing from my experiment. A control. And I did not think about it at the time. But one thing I could have done was set up another piece of paper of each color with nothing on them and not put them in the sun. So then I would have one piece of paper that did the experiment and one that did not. And we would see it. So I found paper from the same stock. So if you believe me on that, then you can see that in fact, the blue is more faded and the handprints are still just about that same original color. Not exactly. Here's the part where there was a lot more sunblock. That is definitely darker, closer blue. So you can see it did in fact fade in the sunlight. And the sunblock did in fact stop a fair amount of that effect. I have all the colors as a proper control. Okay, purple. Yep. Faded and the handprints are not as bad. Pink. Faded and the handprints not nearly as bad. Well, here's another thing I figured out while I was setting this up. Even if you don't believe those came from the same piece of paper, I happen to be doing this, practicing, and notice the back of the paper. There, unbeknownst to me, is my control. The back of the paper didn't fade at all. So you can see, in fact, the experiment worked. Yay! Sunlight faded the color, not nearly as much, hardly any, in the sunblock area. And all three of them, oops, showed the same thing. There's the original color next to the fade. Even the pink, which is a lot harder to see because the pink was already a light color to begin with. But also it wasn't in the sun as long, so maybe it would have faded more. Don't know. Would have to run another experiment. All right, so that's experiments, some basic principles. Let's go on to our microbial box. So here is an introductory video from 2016 Mission X for the microbial box.
Hello from the International Space Station. I'm Kate Rubens, a Mission X ambassador, and I'm living and working on board the International Space Station. Our crew is taking part in similar physical and scientific activities as you have done with Train Like an Astronaut. Today, I would like to discuss microbes, which are very small organisms that live all around us. Microbes can be bacteria, viruses, and fungi, and there are kinds that are good and kinds that are not so good. In order to stay healthy, we try to maintain the healthy microbes and minimize contact with microbes that are bad for us. Here on the ISS, it is similar to your school and your home in that we have microbes in the air we breathe, the surfaces we touch, and even living inside of us. We need microbes in our lives. Let's take a look at a few examples where microbes live. First, let's look at an example of a microbe on station. Socks. The microbes that make socks stinky are bacteria. Those bacteria aren't necessarily bad for your health, but your feet have hundreds of thousands of sweat glands, and inside of your shoes is a warm environment for the bacteria to grow. That can get smelly. And next, tortillas. We have tortillas on the International Space Station. Many breads contain yeast, which is a fungus that's helpful in making some kinds of food and isn't bad for us to eat. I will look forward to reading about what you learned about microbes by doing a microbial box.
Okay, microbial box. Today is observation day. I meant to say this on the first intro session, and I forgot, I'm sorry. If you don't have any of the items that we put in our box, or you did not get permission to do the box, it's okay, don't worry. You can use my microbial box with me. I'll describe what I'm seeing and smelling, and I'll try to show you on the video too, okay? All right, now, our version for Train Like an Astronaut at Home of this activity is actually a cross between microbial box and another science experiment from Mission X called Bugs in Space. And because of that, I kind of made it a hybrid. I've taken things out from both and kind of put them together. I don't actually know what to expect for results here, okay? Let's see. So, if we go back in our mission journal to microbial box, and we had written down what day it was, and then today. So these items have been in our box for a little short of 5 days, right? We did session 1, so a day to session 2 to session 3, skipped a day, then session 4. It's now session 5, but it's a couple hours earlier in the day, so it's a few hours short of 5 days. So on a new page in our journal, we are going to write down today's date. I keep checking my watch because it's much better at keeping track of the date than I am. We're going to write down microbial box day 2, or you can write session 5 or whatever you want. And I'm going to write it is been 4 days and 24 minus 3 is 21 hours. 4 days and 21 hours since we put the items in our box. Okay, quantitative data. Now, let's see. So in my box, I wrote down, I put in a sweaty sock, just like our astronaut friend had, 2 slices of cheese, different kinds, 1 slice of wheat bread, 1 soft flour tortilla, and a small handful of peanuts. And at home, you of course may have done something different types of cheese, different type of bread, split peas or coffee beans instead of peanuts or anything else. Or you might not have had all this stuff, and all of that is fine. So we are going to open up our microbial box and we're going to write down what we find. Okay, firstly, let's find the sock. Here it is. Let's see. All right, so this sweaty sock, even astronauts have sweaty socks on the International Space Station, we just learned. So there are microbes there. Now, I don't see anything different from when we put it in. Oh, but I certainly smell. Yeah. That is, and you can still smell it. Woo! Okay, so yes, microbes. We're going to say sweaty sock. I'm going to write down, doesn't look different, but there was really a very strong, what kind of odor would you call that? Very strong, bad odor, but I want to qualify it better than that somehow. I just can't seem to right now. All right, that's good enough. Let's move on. All right, our bread. That's the next thing I've got here. Tortilla and bread, slice of bread. Now, these look the same to me also, although I am seeing a lot of crumbs. You see down in there from the slice of bread. Let's see if I can see between the two of them. Yeah, they look normal. Really, I kind of hoped the bread was gonna be growing something, by now. If you've ever left bread on your counter for a week or two, I guess two because this bread's fine. Sometimes you open it up and there's mold or something growing on it just because of those microbes. Okay, open it up. Actually, it still even smells fresh. Perhaps the plastic bag helped keep it fresh. The only way to know would be to run another experiment where I take bread and put it in a plastic bag and bread and leave it out and then see what happens after a week. All right, so we're going to write down our bread and our tortilla. I can't spell tortilla, apparently. They look the same, and they smelled fine, as if fresh. Okay, next, cheese. So there's our 2 cheese slices, or at least mine. Oh, and I can already see, oh, yuck. Can you see that? There's like this orangish liquid in there. I'm not sure I want to open this and smell it. Okay. Do not see anything odd about the American cheese slice, but the cheddar cheese slice looks like it has a small spot starting to grow right there. It's definitely darker and not orange. I don't know if you could see that. So, cheese. I'm going to write down the American. Looks normal. No change. The cheddar appears to have some sort of liquid. I don't know if I could call it a juice or a slime. I don't know if any of those words are quite correct. So I'm going to say some sort of liquid next to it and around it. Next to and around it. And then I'm actually going to draw this. I'm going to draw roughly the shape of my piece here, and I'm going to put where that spot is. Yep. Shade it. And then I'm going to say there is a dark spot that is new. Right there. So there's my mission journal and the part with the cheese, and there's my image, my picture. So that is a whole lot easier than trying to describe how big and where on this piece of cheese. Right? Okay. Should I open it? Well, in the name of science, right? Okay, 1, it didn't smell as bad as I thought, but 2, the plastic around the cheddar does not want to open. It's kind of, yeah, it's kind of stuck together. There we go. There we go. Doesn't smell bad, but it certainly doesn't smell like the cheese. Or at least did to begin with. I'm not going to touch it because if I did, I would have to wash my hands afterwards, and I need to be able to use my pen and touch my computer. So, American cheese looks normal. There was no change. Smelled okay. I probably wouldn't eat it. As a reminder, do not eat any of this. It's been out of the refrigerator too long. Smelled okay, wouldn't want to eat it. The cheddar, how do I say, the plastic did not want to come off of the cheddar. Plastic stuck strongly to the cheddar. And then, while it did not smell bad, it did not smell like cheddar cheese. Okay. What's left? I have peanuts left. Oops, let me write. Didn't smell like cheddar. Okay. Peanuts. They're all still there, of course. They look fine to me. There aren't even as many crumbs. Like, there was a lot of crumbs with the bread. I forgot to write that down. They still smell like peanuts. I think they're perfectly fine, which honestly doesn't surprise me. Peanuts are pretty hardy. They can last a long time. And this was not even quite a week. Peanuts look the same, smell the same, appear normal. All right. What results did you find in your microbial box? Remember to throw this stuff out, unless you want to throw your dirty, smelly sock in the laundry to get washed. Everything else should be thrown away. Don't eat it, don't reuse it, just junk it. Okay. Let's think about this and our results. Say bread had given off lots of crumbs. Okay, the sweaty socks. There was definitely a change. There was definitely a strong odor there, a smell. And our astronaut friends said that that was caused by microbes that had come from our foot. Okay, the cheese. While the American cheese didn't really change, the cheddar cheese certainly did. That liquid. So here's one of the things. Some people would say, our experiment showed there are microbes there. The microbes in the cheddar cheese had done their thing and created this liquid over these days. And that might be right. But if I think about it, I can think of another explanation. What if the cheese just kind of melted a little and kind of oozed off itself? That wouldn't have anything to do with microbes. I don't know. Both are explanations. I don't actually know which one is right. This experiment wouldn't answer which one of those is right. We'd have to design an experiment specifically to figure that out. However, there was a dark spot on the cheddar cheese. That we can be much more confident was microbes growing. The cheese, yogurt, things like that have what's called active cultures in them. So little microbes that are actively growing helped make these things. And eventually turns into mold. That's what's growing. Bread and tortilla seemed fine. In fact, our theory is that the plastic bags kept them fresh because grains tend to do better that way. Again, we'd have to run a different experiment to know for sure, but didn't see any change. Does that mean there are no microbes in there? Actually, it doesn't mean that. We did not prove there were microbes. We did not prove there were not microbes. The split peas or the peanuts or the coffee beans, whichever you did, again, we didn't prove if there were microbes. We also didn't prove that there weren't. So, another question that Mission X posed for this is, after our observations and what do we think about it and all of that is, are any of these microbes dangerous for astronauts? So, the microbes in sweaty socks, are they dangerous? Probably not. A bad smell is not pleasant. Nobody likes it. But it's not actually going to hurt astronauts in outer space. The cheese, the mold growing on the cheese, or whatever microbes are in there, could that be dangerous? Yes, if they ate it, it could make them sick. And if they breathe it, who knows? I mean, so want to be careful, take care of those kind of microbes. Bread and tortilla wraps. Don't know. We don't even know if there were any microbes from our experiment. Now, our astronaut friend told us there was yeast in them, which is a microbe, and everyday life eventually shows us that there is. But In the short term, the bread giving off crumbs is much more dangerous than just bread or tortilla wraps in general, the microbes that are in them. Split peas, peanuts, coffee beans, wouldn't even know how to, I don't even know if there are actually microbes in them. So I don't know. I can't really even guess on if they'd be dangerous or not. All right, I'm getting close to done here, but like every day, we need to do our spacewalk, okay? Get my phone so that I can have my timer. Quantitative data. Okay, let's see. Clock app, stopwatch. Their walk is hands and feet on the ground facing down, and go. Do my 30 feet, get here, turn around. Oh, don't hit my head on the way. I was going too fast. Okay, even though we're pretty much done, I'm still going to write this down in my mission journal. That's what good scientists do. Date. Spacewalk. I did the bear walk. Took me 10.5 seconds again. I haven't sped up on that at all. 30 feet. Okay, crab walk. Let's see. We're going to reset. Get down here. Hands and feet. We're facing up this time. Get backside, your bottom, your butt, whatever word you like, off the ground. And go. Do your whole distance, whether it's 30 feet like me, or 40 feet if you have it at home. I kept going, got myself up the whole time. 11.5 seconds. Wow, I'm doing great on this. 11.5 seconds, 30 feet. And you know what? I feel fine. My back might have something to say about that later, but right now I'm okay. I'm not even winded. This is good. So we can go back, we can compare with all the other days, crab walks, bear walks. There's more down there. If you wanted to, if you had access to software that does that, you could graph it. You could graph it on paper yourself, make a chart if you know how to do that, and put your data points on and see. You can see your progress and see how it's going. That's more science and more data. We're not going to do that right now, though. Lastly for today, for this session, virtual space camp. So this Train Like an Astronaut at Home series was to launch the new virtual space camp website. It is at virtualspacecamp.net. URL is over there. You can do it either just by itself, or you can put the https : whatever those 2 slashes are, virtualspacecamp.net. Either one of those will get you there. And there you can get your certificate. Now, for those of you watching it live, you're going to need to give me 24 hours to get it all set up and fixed up. But yes, I'm going to show you right now how. So here is Virtual Space Camp. Hang on, I know I need to slide it over. One more time, come on. There we go. Virtual Space Camp, all right? So scroll down. There's a lesson on the solar system, which has multiples in it. Then there's the Train Like an Astronaut at Home. Again, scroll down. Now here, you see there's a very faint arrow in a circle there. Click on that. All the sessions are in there. This one we're doing right now will go in a few minutes. And here are the certificates you can get. So there's one you can just download, put your name on it. The other ones, there will be two others. Depending on what level you did, you're going to have to click more, or you can click on the picture or the header, and you click, and it's going to ask you to sign in, log in, or however, but create an account, put your name in. That way, we know you did this and that you have earned this certificate. Now, anyone who has done just parts of this and not the whole thing, you can get this first certificate, no problem. You just need to go there and download it. But if you did the whole thing all the way through and you were paying attention, you can get this certificate. Now, if you kept a mission journal, there's going to be another certificate also that you're going to have to sign up for, and then put in not just your name, we're also going to have you put in stuff from your mission journal, either take pictures and upload, or type in so that we know you really did this whole program. Congratulations. Thank you so much for doing this with me all week long. Really excited. You have now trained like an astronaut at home. Great job. And I hope you will keep it up. Keep up training, keep up nutrition, keep up exercising, keep up practicing coordination, keep up thinking like a scientist. Have a great day.